All right, welcome back, chat. Today we are continuing in with our partial fraction decompositions. The examples that we worked last class were when we were trying to decompose something where the denominator was split into distinct linear factors. So we didn't have any repetition going on, nothing was weird. For this example, and I'm just going to spoil it first, we're going to look at repeated linear factors. And the good news is that this doesn't really change a ton, but it does make the problem a little bit more challenging. Okay, so we haven't even jumped to quadratic factors yet, but we're going to get there. For this, here we go. I want us to decompose the following. We have 3x squared, love it, minus x plus 5. And all this is going to be divided by x cubed minus 2x squared plus x. Cool. Now, right off the bat, if I hadn't told you this was repeated linear factors, you wouldn't notice it yet, but the same step the first time is what's always going to happen. How do we start a partial fraction decomposition? I need to know how many pieces, right? How do we determine how many pieces? Check your notes if you need to. There's two words that I would use to do it, but you could make it wordier to be a little bit more clear. Like the two examples that we've worked have had two pieces, right? A and B. Why two? Okay, what's step 2 of our guide? Step 1 is say, check if it's improper. It's not. What's step 2 say? Factor what? Let's factor the denominator. Like every time that we're doing a partial fraction decomposition, it's always going to start with factoring it. So I'm going to do some scratch work over here. And the good news is that we get a bunch of practice still factoring these. So before I just rewrite this blindly, what's the first thing we're always going to check when factoring? Louder and prouder. Because I heard Ken whisper it, but I also heard it whispered over here. GCF. Is there anything that you guys can see that goes into x cubed, into x squared, and x? X. I'm going to factor out the GCF right off the bat initially. It's an x. What does it leave behind? X squared minus 2x plus 1. Okay, here is a prime factor. I cannot simplify that one anymore. Just can't do it. The second one that's inside, it's quadratic right now. We need to see if we can factor it further as well. Right off the bat, there's something that I noticed about it that's so nice. Abigail, you might notice it as well. Maybe. What is nice about that trinomial inside the parentheses? Oh my, leading coefficient is 1. Why do I care, JB? Shortcut. Can you guys think of factors of 1 that add up to negative 2? Negative 1 and negative 1. Now, in reality, I think about perfect square trinomials here first before I check the shortcut, but it's equally short. With that done, I can see that here are my factors. X minus 1, and x. Do you guys agree with that? Now, I'm going to rewrite this one slightly different way, one step further. It's going to look nicer, but it's also going to line up more specifically with how we wrote our guidelines for partial fraction PFDs. Here we go, x times x minus 1 squared. As soon as I notice, and you probably noticed it before that we had a repeated factor, we have it showing up more than once. This is the weirdest thing that we deal with, but when we look back at the list, and the language isn't, I don't think, going to be word for word the same, but I do want to just show you mine. What a weird thing to see on that. Okay. Focus. Cool. As we look at it, if it was repeated m times, remember we did it to the first power, then to the second power, then to the third, all the way until we got to the mth power, however many times it repeated. So if this had shown up 5 times, I would have the factor to the first, and then to the second, the third, the fourth, the fifth. I'd need 5 new pieces. This one is nicer. How many pieces or how many times did that factor repeat itself? twice. And there's one that didn't repeat, right? Okay, we may have to mix and match. We're always, unless we do one together, we're probably going to do a little bit different parts. But let's check it out. I'm going to just write it here. If you guys do it here in your notes, do you get to see what like clearly happened? Or is that too odd? I'm going to take the time to redo this real quick. 3x squared minus x plus 5 over this. I'm going to go ahead and write it in its factored form since I already have it. Could I write it like this instead? Same thing, right? Like whichever way, this is shorter. Equals, now let's just see. I have two factors, but one of them has repetition. The first one, purely arbitrarily, doesn't have to be. I'm going to make it a over x. Plus b over, and big moment of truth. What do you think we should put in the denominator here? We're on that repeated factor now. X minus 1. Good. And you didn't specify it, which you don't have to when we do this, but to the first power, right? Because it repeated, I need to have x minus 1 again, but it's going to go with my square. So we get an extra piece this time. C over x minus 1, and now it's to what power? The second. We simply have 3 pieces to deal with. I'm going to get rid of the scratch work for the factorization over here so that I can do my stuff on the screen. Before we move on, it repeated. We had to do a little bit more work, but still manageable. There are situations where things get kind of strange in here. I'm going to try my best to avoid them because we didn't do one section that might help us with this. Once we get here, I think we can start cooking. I don't like fractions, but I know what the common denominator is because we've gotten those factors from it. I'm going to multiply both sides of this equation by what? Now I'm going to do it like this since they're all common denominators. How do we clear all the fractions? So when you say by the reciprocal, love it and hate it simultaneously. Which reciprocal? Because I have 4 fractions here. Good. I'm going to multiply both sides by this expression, x times x minus 1 squared. Both of them. Now, because I'm only doing it in one form, remember that even though we had the equal sign between them, I'm just going to distribute this to everything. The left side is easy. I'll do that one. I get 3x squared minus x plus 5. I want you guys verify for me that your algebra here is okay. The left side gives me this, 3x squared minus x plus 5. And if you're careful, this should only take a minute. But I want you to find me what's left on A and B and C. I'll give you a moment, and I'll call in somebody random. I'll come around and check and help if need be. My biggest advice is don't cross stuff off, because you're going to wind up leaving it behind. When I do this one, A over X times this, can you tell me without scratching it and writing it down which part will fall out? X. Now, I'm going to undo this immediately, but it's like, whoa. It's like that and that are gone in this situation. I wouldn't really cross it out, just so you know. Cover it up with your fingers if you have to. I'm going to be left with A times what's left? X minus 1 squared. So there's my first term, A times x minus 1 squared. Plus B times something, and let's just think about it the same way. There's how many x minus 1s written here? There's really 2 there, right? Only how many of them are going to divide out? So if one of them divided out, what's left behind? So they're gone. And x times x minus 1. So this is going to get ugly for a second. X times x minus 1. Now, if you have the urge to actually distribute it, I would hold off. That didn't seem to click. So you could. It would be x squared minus x if you wanted to. Because what we really see going on here, and just in case for whoever it's not clear for, I'm going to write this out like fully. What divides out? And then we're left with an x and an x minus 1, right? This is what I'm doing. My hope And my encouragement would be try to do this mentally rather than doing the scratch work for every single one, because what we multiply by is going to work out super nicely every time. And I can keep that up there. All right, how about on the C? This x minus 1 squared divides out with that one, yeah? And we're left with what? Just an x. What's the name of this equation? Like, that sounds crazy and maybe it doesn't mean anything, but I think we have a definition. It's a something equation. It's true for every single x, I know that. It's the basic equation. This is the key. From here, we're now going to use this to solve for every little part of this. So, I don't care which one we solve for first. Do we want to solve it together? Do you want to, let's do one together and I'll have you guys do the other two. Without any preference, do you want to solve for A or B or C as a group? Like, with me included. Which one looks the ugliest? So B looks the ugliest to solve for, right? What's up? What do you mean just one? I'm going to solve for one of them, and you're going to do the others. So as I'm looking at this and I'm trying to make this decision, I can solve for A really easily. I can solve for C pretty stinking easily as well. Can you guys tell me how I know that, or what I'm looking at to make that determination? Yeah, how do I make A and B 0? What's the easy choice? If I choose 1, A and B fall out. Okay, if I'm trying to solve for C, well, that's what I just did, I'm sorry. If I'm trying to solve for A, is there a way that I can pick an x value that makes B and C both 0? 0 would work, right? Because they both have x as a factor. Now, as I look at B, it's a little bit more challenging because it doesn't seem like there's anything specific that we can do for A and C. That's okay. Let's solve for the ones that we know first, and then we'll come back and see if maybe we have enough information all of a sudden to solve it for the other one. It's probably going to be a little bit of substitution, which I'm okay with if you guys are. But let's check it. Let's solve for A first. We're just going to do this whole thing together, and then I'll have you guys try one either in your notes or on your homework. We'll see. Solve for A. Okay. To solve for A, I'm not going to write it, but it means I have to eliminate which terms? B and C. Now, I noticed that both of these have x as a factor, and you guys had already answered this. To solve for A, let's let x equal 0. And I'm not going to change colors as I go through here, but I'll show like all my work. Anywhere that there's an x, what am I going to replace it with? 0. You may not write all this, just so you know, and I totally understand if you don't, but there's what happens when I plug in 0 on the left. Most of you, I assume, can tell it's just 5. 0 plus 0 plus 5. Okay, this A term, big moment here. I'm showing way more work than you guys would. I'm okay with this. Where do you think I'm concerned about you making a mistake in this problem? Specifically with that expression, just with the A part so far. If you square -1, what should it be? It should be 1. What do you think somebody in here inevitably will get? The -1, because you're going to lose track of the square and the negative. Okay, for this next one, are you okay if I just do this? And I'm not going to write any more with it. And plus C times 0, and it's also gone. Can we solve for A? What's A? A equals 5. Okay, we've got it. Now, B is kind of challenging to do. So if we can't eliminate it just by itself, let's do C, and then we'll come back and we'll hit B together. I want you guys to pick a value of x that works and solve for C as well. So this is your group, neighbors, whoever. Solve for B. And I'm going to give you a minute. So, huge typo right off the bat there. Remember, B is a weird one. We are solving for C because it's easy enough to eliminate A and B. What did you guys use for x? 1? Cool. Once you have an answer, go ahead and check the board and let me know if it's the same answer that I got. Before you erase. So careful. Why isn't it 9? So it's also not negative 9. What happens first? Okay. We now have 2 of the 3. Remind me real quick, this basic equation, it was true for which x value? Value or values? Every single one of them. This is true for all x. This is an equation that must be true because we started from unknowns. Now, we don't have a good way to solve for b, right? So whether you write this down or not is entirely your choice, but I'm going to just write down a little bit of logic stuff here. We don't have, and I'm going to pick a different color. Let's see, green feels okay. We don't have a convenient choice or an easy way, or any way for that matter, but we don't have a way to eliminate A and C. A and C to obtain B. Like, that's just a wordy version of the issue that we encounter here. However, I want to stress how cool that basic equation winds up being. It's true for which x values? My basic equation, true for Angel quietly and confidently whispers all. We know it's true for every single x value that we could ever pick. So anyway, we don't have a good way to eliminate A and C to obtain B. However, we do have another trick, quote unquote, or logical use up our sleeve. Do we know A? Do we know B? Do we know C? So we know 2 of the 3. And Sean, I liked your idea. There are going to be cases where we have to use a system to solve this. However, we know 2 of the 3, and this is true for which x? The basic equation, I mean. All of them. Let's use A equals 5, C equals 7, and literally any other x. Now, we could pick 433,712 if we wanted. Unless you guys have a better number to suggest, we will use a terrible 6-digit number. Give me an easier one. Can't use 1, we've already used it. It eliminates stuff. Let's use 2. Like, that's the next easiest option. You have infinitely many choices. And I'm going to switch to a different color. We'll use this dark blue. Let x equal 2. Now, we're going to solve this for b, and we're going to let x equal 2. So here we go. If you don't need to show all this work, you don't have to, but anywhere there's an x, I'm going to replace it with a 2. So 3 times 2 squared minus 2 plus 5 is equal to, what do I write here? Love it. 5. It's a. We already have a. Cool. 5 times 2 minus 1 squared plus b, we still don't know it. That ends 2 times 2 minus 1 connected to it. Plus, gosh, what's c? 7, and I'm going to plug in a 2 here. I typically do not write this. I don't care if you really and truly write this, as long as you don't have a mistake in your mental math part. Solve b for me. Cool. Nothing crazy. What's your calculator for? Just you can use it, but I'm just curious. Which part? Okay, that's fair. Looking into this, thank you, sir. Looking into this, looks like b is -2. Are we done? We are really close to being done. It would be a shame if I put in all this work and all this time into solving it and I just didn't write the answer. We were actually looking for the partial fraction decomposition, right? We have found A, B, and C, which represent the numerators. The reason that I stress writing this part so detailed is this is what my answer is going to look like. I have the ability to just copy and paste. You guys, it's a little bit more tedious, but check it out. Here it is, and I can see everything that I need. I'm going to get rid of A and B and C because we're going to use the appropriate values. What's A? 5, and I'm going to let you guys catch up because you can't copy and paste on your paper probably. Unless you have some Play-Doh, maybe? I don't know. 5? With Play-Doh? Yeah, I had a fancy chisel that I'd use occasionally too. What's B? Okay, does this annoy anybody if we do it like that? What's the alternative? You could do minus 2 over x plus 1, and boom. Look at that. We now have 3 simpler fractions that in here we don't get to see why, but every single one of those is a million. I don't know the number really. It's so much easier than dealing with the entire thing as a singular piece. The problem gets a little longer, but did the method really change? We add the clever trick with knowing 2 of them. Pick any other x. Cool. All right. There's one more type of problem that we haven't done, but I'm trying to decide if we need to. What do you guys think? Interesting, not what I was expecting. We'll see this again in calculus, but it's pretty advanced calculus where this kicks in. So here's what I would like to do. I want you guys to get some practice on your own. Okay, so at this point in time, you get the privilege of homework 7.6. You will find this assignment waiting for you on page 506. And let's see, we get 18 minutes right meow. I want 17, 22, 25, and 27. That's it. Guarantee I'd take it tomorrow after lunch because it's finals schedule. Cool. All right, before you guys get into working on this, I do want to be able to talk. What's up? After lunch. 1 and 2 before lunch, and then 3 and 4 after lunch. In the morning, yeah.
Wait, we get English first.
Oh, I'm 4th hour, but you'll still have me tomorrow, last hour of the day. Yep. Okay, so we do need to have a discussion. You guys, if you want to grab your textbooks and open them, you should, because I need you to see this stuff. Okay, here's the homework for tomorrow, and the rest of it will show up when we look at tomorrow's video, so I'm going to end the video here. Real quickly, Riley was not here just now during our break. So anything that you guys want to say?
Good job, Riley. I love you.
job, Riley.
I love you.
Okay, real quickly. Riley, disregard that.
What?
Is there anything you guys want to say? All right, much better. Cool. All right. So, as you guys are